Hello, my name is Chad Varney, and I'm an application engineer here at Ally PLM Solutions. I'd like to welcome you to another session of NXCam Lunch Bytes. Today we're going to look at turning in NXCam. We have several of you on the line with us today, so you'll be in listen-only mode for the session. If you've got any questions after the session, you can email those to me at chad.varney@allyplm.com. I want to remind you that we have all of our Lunch Byte replays available up on our website. You can check those out at www.allyplm.com. We also have a section where you can give us your suggestions for future Lunch Byte topics. So today I want to look at some basic steps to getting started in turning in NXCam. First, we're going to look at different ways to define your blank geometry. We're going to look at using existing solid bodies to create our blank geometry. And then we're going to look at defining our blank geometry using a part spun outline or a blank spun outline within the manufacturing setup. Then we're going to look at creating avoidance geometry. We'll also look at creating containment geometry. And then we'll look at how to create a variety of different turning operations, facing, OD roughing and finishing, OD grooving, drilling, ID roughing and finishing, and ID grooving. So let's take a look and get started. This is the part that we're going to work with today. You can see that it needs some OD operations as well as ID operations. It's got a groove on the OD and then a groove on the inside. And then you can also see that we have our solid body that's representing our blank. So we're going to use that as our blank geometry. So let's get started in manufacturing. I'm just going to go to File, New. Under the Manufacturing tab, I'm going to use the turning template. All right, and the first thing we notice in the turning template, if I go over to our machine tool view, we have a turret and then 8 stations. And then 2 tools were created for us, an OD roughing tool and an OD finishing tool. While I'm here, I'm just going to go ahead and create a groove tool for this outer groove. That way we're set up and ready to go for our OD operations. I'm just going to create a tool real quick. OD groove tool, put it in station 2. All right. Next we're going to go to our geometry view. And we notice that we have MCS Spindle, workpiece, turning workpiece, and avoidance. We're going to go through each one of these of how to get this set up properly. The first thing I want to do though is I want to turn off this blank shape, this body. We're going to look at some different ways to create our blank. So I'm going to turn this off so that's not in our way. I'm just going to put it on another layer. I'm just going to put it on layer 50. Okay. So I'm going to double click on MCS Spindle, and this already has the MCS or our machine coordinate system already set up the way I want it. So we really don't need to do anything here. Obviously, if you wanted this in a different location, if you wanted it on the back side of the part, you could change that there. But I'm gonna leave this the way it is for now. All right, now I'm going to define the workpiece. I'm going to specify my part just by simply selecting the part. All right, and I'm not going to use specify blank yet. Again, we're going to look at some other ways to specify the blank. We'll use this in just a minute. All right, now when I left click on turning workpiece, you'll notice that it basically turns this into 2D geometry. All right, I'm going to do Control W and bring up the show and hide, and I'm going to hide in solid bodies. And I'm just going to go to a top view. We can see that this created basically 2D geometry that we're going to use for turning. If you don't have 3D geometry, you can use 2D geometry as well. but we had 3D geometry, and NX automatically turns that into 2D geometry for us. So this is the outline of our part. Now we're going to look at a few options for defining our blank. If we don't have solid geometry or a solid body to use as our blank, you can define your blank this way. We're just going to go under specify blank boundaries. All right, and we can define a blank stock using bar stock. Okay, so I'm just going to select my mounting position. It automatically defaults to 0. I want to start that about 1/4 of an inch away, so that we have some material to face off on the front of this part. Okay, I'm going to set that to away from headstock, and then the length I'm going to set at 7 inches, and then the diameter is going to be 12.5. All right, so you can see this is defining our blank outline or our blank bar stock. So if you're starting from a piece of bar stock, this is a good way to define your geometry. All right, if we're starting off with like a tube or bar stock that maybe already has a hole drilled through it, you can use the tube stock option. Okay, it's the same thing as what we just looked at in bar stock. The only difference is you can use inner diameter. All right, so I'm just going to put the inner diameter at a 3 inch. And we notice that this has a 3-inch diameter hole through our blank. All right, so that's going to save us time. When we calculate turning operations, NX uses our IPW, or in-process workpiece. So if we do turning operations on the inner diameter of this, they're going to start right here. They're not going to start out in the middle or anything else. It knows, because we've defined it as a tube, it knows where to start our operations from. So the operation is going to come from here to here for our ID turning. So if that's the shape that you have to start off with, that's a good option to use. All right, next is if we have maybe a casting or a forging, and we want to offset the outer perimeter of this part, we can do that by using from curve. Okay, this has already created 2D curves for us, or a boundary around this, so I'm going to use those and then offset those. So I'm going to pick curve boundary. I'm going to chain this. All right, and then I'm going to just offset this equidistance of 1/4 of an inch. All right, so here we see we've offset this geometry by 1/4 of an inch. So if that's what you're starting from, that'd be a good option to use. And also, it's going to save you a lot of time, like I mentioned with the OD. Same way on the OD is you can define this, and you don't have to do near as many roughing operations. So that's going to save you a lot of time if this is what you're starting out with. But as I showed you before, we do have a blank solid body on this. So I'm going to go ahead and use that solid body. I'm going to go ahead and turn that layer back on. And I'm just going to go back into workpiece and define my blank as this solid body. All right, and then I'll left click again on turning workpiece, and you'll see that blank was created in 2D form. All right, and I'm going to go back into layer settings and turn that layer off. We won't need to see that anymore. Back to our top view, and next we're going to take a look at avoidance. All right, you can see in the legend it kind of gives you a description of what these mean. I'm going to set this up so this avoidance is going to be set up for our OD operations. I'm going to do OD operations, and then we're going to come in here and do these ID operations. But I'm going to set up two different avoidances. So I'm going to set this up for the OD. All right, so our from point, I'm going to define our from point, basically where your operation is going to start from. I want this kind of way out here, away from the part. This would be a good area where close to maybe where your tool changes are. So I want that pretty far away from the part out in the open. So I'm going to set that. And then motion to start point. I want to go in a direct motion. The start point is going to be an area close to where your cutting is going to take place. For OD, I want it somewhere around here. Now for ID, I don't really want my cutting motion to start here, because then we have a chance of interfering with our part. So we don't really want that. So that's why I'm going to set up two different avoidances. So for this one, I want my start point, I want to go directly from here to the start point, and I want my start point to be out in this area. And I'm just going to type in those values, 1.5 and 6.5. All right, so this is where our start point is going to be located. All right, what type of motion do we want to use for our engage? All right, it defaults to direct, and that's obviously going to be your fastest way to do it. I'm going to leave this set to direct. So for an example, if we're turning this outer shape here, it's going to do a direct motion to the start point and then turn this outer shape. Now you got to keep in mind, if you're doing, let's say, this groove shape here, it's going to do a direct motion to your start point. So you have to be careful that you don't gouge your part, and we'll look at that here in a minute. That it's going to show you a little bit of a warning. So you just gotta check that when you do your operation. But for now, we're going to use direct. Okay, and then next we're going to set up our motion to return point. I want to do our return point. I want to just, when we're done cutting, I want to go back to this point. All right, so I want to do a direct move back to this point. So I'm going to set this as same as from. Okay, so another example is if you're turning this outside shape, it's going to go around here, and then it's going to do a direct move back to this point. And then after your operation is finished, I want to do a direct move back to this home position, or this from point. So I'm going to set the home position to be the same as the from point. So we want to go back out into here into this safe area. Okay, and as I mentioned, we're going to use this for our OD turning. So I'm just going to name this OD avoidance. And then what I'll do is I'll just copy this and paste it, and then I'm just going to edit this. And really, the only thing I need to change for ID was what we were talking about, is a start point. So I'm just going to drag this start point down to here and set that at 1.5. So now our ID turning operations are going to start from the center and work their way in. So a little bit safer way to do it. I'm going to still leave everything in direct, but again, when we get into this groove operation, we may need to change that, and I'll show you how to do that within the operation itself. Okay, and I'll go ahead and rename this. All right, and then another good practice would be setting up containment. Containment is basically your limit. We'll do that by creating geometry, containment geometry. I want this to be a child of OD avoidance. Right, and I'm going to call this OD containment. All right, so as an example for radial trim plane, if you only wanted to cut, let's say we only wanted to cut from the outer diameter just to here, you could set up a radial trim plane to here, and it's only going to cut that area. All right, we're going to cut this whole part, so we really don't need any radial trim planes. However, we do need an axial trim plane. All right, so what I'm going to do is I'm going to set the axial trim plane, and this is going to limit our cutter path. It's going to limit our tool motions. All right, I don't want to limit it right to the edge of this. I want my tool to be able to come just a little bit past this. We don't have leave a burr or anything on our part. So I'm going to change this to -5.5. oops, negative 5.75, so that our tool can come just a little bit past the backside of our part, but we know that we're going to be, our chuck is going to be in this area, so we're going to limit our tool so that it can't go past this axial trim plane. All right, and then I'm going to define another one as our start position. So our tool is going to be able to go between these two axial trim planes. Now I also want to mention that we can override this within the operation, and we'll do that on a few operations. So just to mention that we're going to override this in some operations, but it is a good idea to go ahead and get this set up and use containment as your geometry. Go ahead and accept that, and then I'm going to use that same containment under our OD, or I'm sorry, our ID avoidance. So I'm just going to paste that inside there, and I don't really need to edit that. I'm gonna go ahead and keep it. Now, if you wanted to, obviously you could, for example, if you wanted to only come to this point with your ID turning, you can set your axial trim plane to this point. But for now, I'm just going to rename this ID containment. All right, so we're ready to get started creating operations now. I'm going to do the OD first. I'm going to create a facing operation first. I'm going to use that OD80 rough tool, and then I'm going to use OD containment, and I want to use the finish method. Okay, so I'm just going to go ahead and change the step over this and generate this. So what we get, as I mentioned before, NX uses the IPW, the in-process workpiece, to define your cut area. So it's going to be using this as we go. Since I have this set on OD containment, this is set to cut from our axial trim plane over here and our axial trim plane over here. I only want to face this part. All right, so I said that we could override that. We'll just go to cut regions, and I'm just going to drag that axial trim plane over to the face of the part, hit OK, and regenerate that. And now we're only facing this part. Okay, we see our from point. This is where our tool is starting from. We're going to our start point, a direct move, doing our cuts, and then coming back to our start point. All right, so that looks good. Now I'm going to create a rough turning operation. I'm going to use that same tool, and I'm just going to change this to a roughing method. Okay, I don't need to set an axial limit. I want my tool to come to the edge of how we have our OD containment set up. So that looks good. Change my step over and generate. All right, now what we notice is the tool was trying to come down into this groove. All right, that's not exactly what we want. We're going to cut this groove with a groove tool later. All right, so the way that you can limit your tool so that your tool won't go down in there is just by changing the reversal mode, and set that to omit and generate. Now you have a nice smooth cutter path. Okay, and we can verify this. Okay, that looks good. Now I'm just going to do a finish path across here. Insert an operation and do finish turn OD. Use my finish cutter, and our method is going to be set to finish. Omit reversals so that we don't dive down in that groove. And generate. Take a look at this one. Okay. So now, as we could see, the yellow is what's left, what needs to be cut still, and the blue is what's already been cut. So all we need to do on the OD of this part is just this groove. All right, so I'm going to do a OD groove operation. Use the groove tool we created earlier. All right, and I'm going to go ahead and set my cut regions. I only want to cut in between these two walls in this groove, so I'm just going to drag these over and use that as my cut region. And I'm going to generate. Like I said earlier, we notice that see this white area around here. This is kind of our warning that this is going into a direct move. This is going to be really close to our part, if not gouge it. So we got to watch for that when you use direct option. Okay, it's pretty easy to change though. If we go into our non-cutting moves, we go to our approach. Our motion to start engage is set to direct. What I want it to do is I want it to go axial and then radial. I want it to go axial and then radial to start. All right, and then our departure move, I want it to go radial move and then an axial. So I'm going to set our motion to return to radial and then axial. And regenerate that. And I'll step through this one. So we're going to axial and then radial. It does our cuts. And then radial back out and then back to axial. Okay. So now the OD of this part is finished. Now we're going to look at the ID. All right, I'm going to do drilling. I'm going to spot drill and then drill a hole out of here to kind of get some of that material out. Then we're going to do rough ID boring and ID finishing, and then we'll cut this groove on here. All right, so I need to create some tools first. I'm going to go ahead and create a spot drill. Just make it a 1/2 inch. And I'm going to create a drill, just a 2-inch diameter drill. And then I'm going to create a roughing ID tool. Okay. And then a finishing ID tool. Okay, and then we'll do a ID groove tool. And also you can drag this around to kind of see if your insert is going to match the groove that you're trying to cut. So we can kind of drag this in there and see if this is going to fit. This looks like it's going to fit okay. Obviously you can change all these settings if you needed to, if you had a different size tool. So I just want to point that out. Alright, that should be all of my tools. Now I'm ready to get started on ID operations. First operation I'm going to do is a spot drill operation. Now I'm going to switch over to my ID containment, not my OD containment. I want to use my ID containment because I want this start point to be towards the center of the part. All right, I'm going to set my depth. The distance is going to be 1/8. I'm just going to go ahead and generate that. Got a spot drill operation. Notice we're coming to the center of the part and then starting our operation. We'll do a drilling operation. Use that 2-inch drill and set to ID containment. Now on this, I want to use a depth option. I want to use an endpoint. I'm going to use this point, the back of our part, and then I'm going to tell it to break through. And a distance to break through, I want it to be 1/8 inch as well. And generate. You can see our shoulder breaks through the back of the part by 1/8. Okay. Now we're going to do rough turning. Rough bore ID. I'm going to set this method to rough. All right, and the same option that we had in the OD, we're going to omit for reversal mode. I'll change my step over again. Okay, that's looking pretty good. Again, starting at our start point in the center of the part. Okay, and now I'm going to do finish turning. So I'm going to create our finish bore ID. And I'm going to do lathe finish. I'm going to omit reversals and generate this. All right, let's take a look at our cut motions. Again, to the center of the part. We go directly to our engage move. Okay. So now all we have left, we can see in this yellow area, is the groove on the ID. So I'll create that operation. Groove ID. Use our ID groove tool. And I'm going to go ahead and set up cut regions just like I had done on OD. So I'm going to just drag these to the edge of the groove. Same way with this one. And I'm going to generate that. All right, same thing that we had on the OD. This one actually looks worse. Our tool is gonna interfere with the part because I have this set to direct. All right, that's not what I want at all. So I'm gonna go into non-cutting moves. I'm gonna change my approach. I'm gonna go axial and then radial for motion to start of engage. I'm going to change my departure, motion to return point. That's going to be radial and then axial. I'm going to generate that. And let's take a look. All right, that looks pretty good. All right, so we've pretty much completed this part. Obviously, the back side of this may need cut off or maybe a second setup for facing like the back side of that part. So, but for the most part, this part is finished. Let's take a look and see what we have in a little bit better view. Let's look at this in 3D. I'm going to hide these surfaces. And then I'm going to turn on our solid body. All right, and I'm going to go ahead and play this through under verification so we can get a better idea of what this is going to look like. Here's our facing operation, our rough OD operation, our finishing OD operation, groove operation, spot drill and drill, our rough boring, and then our finish boring, and lastly our ID groove. All right, so that gives us a pretty good idea of how we're going to cut this part. Again, want to make mention of how we set up our containment and our avoidance. So really, those are pretty important steps of how those get set up. Just one more thing before we go. We looked at this through verification. I just wanted to make mention, if you click on an operation and click Show 3D IPW, it's going to show that the current status of that in-process workpiece. So after I do my finish turning, you can see what the in-process workpiece looks like. Notice I haven't done the groove yet or anything on the inner diameter, and then you can just refresh that. And if you want to see what your part's going to look like without having to go through verification, you can just simply click on the Show 3D IPW, and it's going to show what your part's going to look like at that point. So this is looking pretty good. Like I said, just need to get that backside off there. So so that's all we have for today. I hope this information was helpful to you. I think this is a good example of getting your avoidance and containment set up. Like I said, those are pretty important steps. We're able to look at a lot of different turning operations, as well as the different options that we have for defining our blank geometry. As I mentioned at the beginning, if you have any questions, feel free to email me at chad.varney@allyplm.com. I also want to remind you that Ally PLM is offering NX CAM fundamentals training, and throughout the summer those classes are half price, so you may want to check that out. You can find more information about all the classes that we offer on our website at www.allyplm.com. I want to thank you for joining us. Hope you have a great day.